Let's go.
Alright guys, so let's solve the question on the board. The question says 500 cm cube of oxygen was collected over water at 30 degrees Celsius and 752 millimeter mercury pressure. Okay, what is the volume of the dry oxygen at STP? We've been given the vapor pressure of water at 30 degrees Celsius to be 32 millimeter mercury, and the options too are given. All right, first of all, let us spell out the parameters that is given so we know the right formula to apply. Okay, solution. The first parameter that is given to us here is volume. Okay, I'll take that to be my V1, 500 cm cube. Okay, the next thing that is given to us is temperature, T1, 30 degrees Celsius. Let's convert it at once. Okay, plus 273 will give us 303 Kelvin. Okay, so the next thing that's given to us here is P1, which is equal to 752 millimeter mercury. Okay, pressure. Now notice that we have been given the vapor pressure of water at 30 degrees Celsius, and the pressure that was given to us at 30 degrees Celsius was 752. To work this out, to have the right value to use to solve for this our P1, we have to subtract this vapor pressure of water that is given to us at 30 degrees Celsius from the one that was given in the question. So what we'll do is minus 32 millimeter mercury. Okay, that is the third thing that is given to us. What next? Okay, the next thing that we are asked is what is our V2? What is the volume of the oxygen at STP? All right, so when you see STP, it stands for standard temperature and pressure. There's a standard value for temperature and there's also a standard value for pressure. Okay, so we want to make use of those standard value. Okay, our T2 now will be that standard value, which is 273 Kelvin. Okay, our pressure, which is our P2, will also be that standard value, which is 760 millimeter mercury. This is a standard value that immediately you see STP, you now apply this standard value. Okay, so now looking at the parameters that is given to us, all right, after we have stated it out, there is a relationship in chemistry that talks about the use of this formula, and that relationship is general gas equation. Now, general gas equation is a combination of Boyle's law and Charles' law. Okay, so and it states product of pressure and volume divided by absolute temperature is constant for a fixed mass of gas. Okay, here is the mathematical formula of it, all over T. Now, just like Boyle's law that we stated that P1 V1 equals to P2 V2. Okay, we also stated that our Charles law is V1 over T1 is equal to V2 all over T2. Now, we want to rewrite our general gas equation formula the same way we wrote for Boyle's law and Charles law. I don't want this video to be lengthy. I would have shown to us how Boyle's law and Charles law combines together, but this is our Boyle's law, this is our Charles law. The combination of these two laws give us our general gas equation. Okay, so let us rewrite this formula to have it the same way we wrote Boyle's law and Charles law. So we'll have this to be, therefore, P1 V1 all over T1 is equal to P2 V2 all over T2. Okay, so in this question we are asked for the final volume. We are asked for the final volume. So we are going to make the final volume here. The subject of formula is simple. Okay, so P1 V1 times T2 will be equal to P2 V2 times T1. So to make our V2, the final volume, the subject will divide through by P2 T1. Divide through by P2 T1. So P2 will cancel P2, T1 will cancel T1. So our V2 now will be equal to P1 V1 T2 all over P2 T1. So let's do our substitution. Our P1 now is 720. When we subtract this, we'll have 720. we'll have 720 millimeter mercury, and our V2 was what we're looking for. Okay, so our P1 now will be 720. Our V1 was given to be 500 cm cube. Then our T2 is given to be 273. Let's divide it. Our P2 that was given to us was 760, and our T1, the initial temperature, was given to us to be 303. Okay, so when we press our calculator, well, okay, 720 times 500 times 273, 98,280,000. Let's divide it by this. 760 multiplied by 303 will give us 230,280. Okay, so 98,280,000 divided by 230,280 will give us 426.78. to have, let's bring the answer here. We can approximate it to have 427 cm cube. Okay, 427 cm cube. The question is as simple as that. Please just do well to follow the way I move the arrow so you understand. 427 cm cube, and that was our option C. It is very simple. It is very simple. All you need to do is subtract the vapor pressure of water that is given at a particular temperature, 30 degrees Celsius, from the pressure that was given at that temperature. Then you have your pressure at that temperature. So that is the one you are going to use to do the solving, and it is as simple as what you have seen me do. Thank you for watching. Please do well to share, like, and comment. Thank you.